Hi guys, and welcome to Preliminary Chemistry and the Metal video series number 7 on metals and electron transfer. In the last video we had a little bit of a look at the activity series of metals and the fact that we can use different reactions involving metals in order to build up a series of which are the most active and which are the least active metals. From that we can identify a couple of important types of reactions that can occur, particularly reactions called displacement reactions. And displacement reactions occur when one metal pushes another one out of a solution. The way this happens is that electrons are actually transferred from one metal to another, usually from the more active metal to the less active metal. This also happens when metals react with acids, but in this case the metal is actually pushing its electrons onto the hydrogen rather than to another metal. Some general rules are important then for us to understand what's happening during electron transfer. Firstly, the more reactive a metal is, the more readily electron transfer occurs. So metals that are very reactive lose their electrons readily and transfer those electrons to another species. Magnesium is one of the metals that we've looked at that is reasonably reactive, and it reacts with dilute hydrochloric acid because of the transfer of electrons between the magnesium and the hydrogen ions which are in solution. This changes both the nature of both the magnesium and the hydrogen, as the magnesium becomes an ion and the hydrogen becomes an atom, in fact a diatomic molecule. This process can be summarized using half equations, and these half equations show the process of electron transfer, electron loss by one metal, and electron gain by another metal or a hydrogen ion. The overall equation can be found by adding together the two half equations and cancelling out any electrons. Of course, we can't have electrons coming from nowhere or disappearing to space, so we must make sure that they are all transferred from one species to another. So let's have a look at a couple of these examples. The first one we're going to have a look at is a situation involving electron loss. When magnesium, solid, becomes magnesium ions, and it will do this whether or not it forms a compound like magnesium oxide or a solution like magnesium chloride, it has lost electrons. These two electrons have been lost. This is called oxidation. Oxidation is loss of electrons. But where do those electrons go? Well, they go here. The hydrogen ions in the solution, which is one of the characteristics of our acid solutions, the hydrogen ions will accept those electrons, and they will form hydrogen gas. In this case, we have reduction. That is, we have a situation where the hydrogen has gained electrons. In this case, each hydrogen ion gains one electron. That gives us an overall reaction that shows just what's happening to these ionic species. The magnesium solid becomes magnesium ions, and the hydrogen ions become hydrogen gas. Notice that there is an overall 2+ charge, and no charge obviously on an element, and a 2+ charge here and no charge on the stable molecule of hydrogen. So now we're not just balancing our magnesiums 1 and 1, our hydrogens 2 and 2, but we're also balancing our charges, 2+ on the left, 2+ on the right. These should always be the same. There should be no electrons because the electrons should actually be cancelled when we add the two equations together. The same thing will happen if we change the magnesium to something like copper. Copper will likewise, in solution, accept electrons and form copper metal. This too is an example of reduction. You can remember these two by the use of an acrostic or an acronym, oil rig. Oxidation is loss, reduction is gain. And if you remember this relates to electrons, it'll help you to identify examples of oxidation involving loss of electrons and reduction involving gain. Thanks for watching.